Okay, let's go ahead and get started. Hi, everybody. How are you all doing today? It's been a long time since I've seen you because, of course, we had too much snow. So, last times we had class, we had snow, and we did not have class. And this is problematic, as you found out. By now, you should have received an email asking you to watch some videos. Did you all get that? How many of you all were able to watch at least one of the videos? How many were able to watch both? Okay, that's what I figured. So these videos that I put up, the first one, which I did last week and totally forgot to email you about until over the weekend, talked about some additional string methods. We talked about while loops, right? And we talked about for loops, at least in the video. And then there was the other video that I posted, I got done yesterday and posted for Thursday. So please watch it by then. It covers some other stuff, and you'll see what's on there. So I promised you something. I said after we watched the video, we'd come in today and we'd have an episode of The Code is Right, which unfortunately was on hold due to more snow. And you can ask yourself, what more snow do we have? Well, it turns out last night we had like an inch of snow, and because they had an inch of snow, they delayed my son's school opening for 2 hours, which was the 2 hours I was going to use to prepare for The Code is Right. So it didn't get done. So I'll tell you, I have a special surprise around The Code is Right on Thursday. I think you're all going to be very excited by this. So on Thursday, unless, of course, we have even more snow, count on that. But we have some other stuff today. But what I'd like to do first, before we get into what we're going to do to start today, is ask if there are any questions. Anybody have any questions? And you all saw the project due dates have been moved, right? This project is not due on Thursday. It's due a week from today instead. You should actually have plenty of time to complete it now. And then a couple of the other projects, Project 3 I moved, and Project 4 I moved, but Project 5 is the same. So I put new dates up. I also created the new syllabus to hand out with all the dates, and I completely forgot because I was late today. So I'll try and remember to do it on Thursday. Yes, question? Mm. Okay, so so the idea here is that you can mix cin and getLine, okay? And what will happen is anytime you use cin, it will get the very next variable that it can reach, right? So if it's an int, it'll get a bunch of numbers, or it'll get anything up to a space. At that point, getLine will get from wherever you read to the end of the line, regardless of how many things are in there. Okay, so cin will read in one blob of whatever, depending what you're doing, and getLine will get everything to the end of the line. Can you remind me which thing that was? I actually have all the code here, and I can take a look at it really fast, and we can. Oh man. Sorry, let me just exit out of this thing for a sec, because when it resizes the screen, I can never get it to go out of full screen. There we go. So, do you remember which one it was? I have all the code here. The snow day video, okay. Desktop. Uh-huh. Was it, I'm just looking through these really fast. Was it string 2, do you think? Uh-huh. Because in this case, I'm actually entering 2 names. Oh, so you're like, why is cin right here as part of getLine? Ah, okay, that's a good question. And that's a very good question. Because I'll show you why. So here's the deal. getLine takes 2 arguments. Like these things inside the parentheses are called arguments, and it takes 2 arguments. The second argument is where to stick the input when you've gotten it, right? So it puts it into that variable. But the first one right here is where to get the input from, okay? And cin is the keyboard. But if we wanted to read from a file, you could replace cin with whatever file IF stream or OF stream you're using, and then you could do input. Actually, it would only be an IF stream. I correct myself. So you could also read from a file using getLine. And if you wanted to read from a file, this wouldn't be CN. It would be whatever the IF stream object it was. Does that make sense? Uh-huh. So what you're saying is it didn't run. Did you try and run it yourself? Uh-huh. This would get all of Adam Smith together and put it in that one variable, because that's what getLine does. It skips spaces and goes to the end of the line, right? I see. Yeah, I've used confusing terminology to try and simplify it for you. And what I'm actually talking about when I say CN breaks on spaces is that the angle-angle operator breaks on spaces. CN is like the keyboard, and the angle-angle operator is what portions up the input for us. So that is a flaw in my teaching method I will have to correct, but you have suffered through it, so you're stuck. So, yes? Yep. Yep. It goes right on to the next line. So when it reads through the file, when you're reading through a file, and I guess I didn't do a very good example of this. Let's see what I did here. Yeah. Yeah, you can absolutely use, I should come up with an example that shows using CN and getLine together. I didn't do that. But essentially what happens is when you're reading the file, or you're reading from input from keyboard, remember how when CN was like expecting 3 variables and we typed 2, it just sat and waited for us? It would wait because it's waiting for the third thing, because it's going to look ahead and find the next thing. The same thing happens in a file. When you're doing input from a file, it starts at the beginning and it just starts reading. And what's happening behind the scenes is the computer is keeping track of where in the file it's reading data from. Okay? It literally remembers I am right here. So the next time you read, it will read the next thing. So if you start by using a getLine, it will get like the entire line. And we're going to have an example of this today. I'll show you in class later. We're going to have an example where it grabs like an entire line, and after it does that, it goes on reading the other things. Okay? So you can think there's like an invisible mark that the computer's keeping track of where it's reading from the file, and as it reads, it always reads from that mark. It's possible to rewind it and do stuff from it, but it's pretty unusual to do that. Yeah. It'll read whatever current line it's at. So whenever it does input, it starts reading at some spot, and it keeps reading along. And when, it never really goes back. Once you've read something, it's gone. It always just keeps reading from where it's read. No, it will get exactly one line up till the end of line, like the return. There's an invisible return marker, which looks like a space to you, right? Because it's just white space, but it's there. Other questions? Sir? Good question. Other questions? So how do you keep a sum of everything that happens in a while loop? And the answer is pretty simple. Did I give you an example with a while loop in it? Let me go back and figure out what we've shown you already. Wow. Okay. That would be the executable. Just make sure I find the right code here. So when there's a situation that you want to count something, like in your program, what you need to do is outside the loop, you initialize a variable, like total or something. You set total equal to 0. And then inside the loop, every time you see the thing that you want to add to total, you add it to total. And then when the loop is over, everything is added up. That's like the simple description of the algorithm. And how about I promise you we'll see an example of that today? Let me just make sure we're going to see an example of that before I make promises that I can't keep. Yes, we're going to see an example of that today. Okay. But in essence, you set a variable outside the loop that's going to be the total. Every time the loop iterates, you add to the total inside the loop. And then when the loop is done, you have added up everything that went through the loop. Well, you can see out it or use it for whatever you want it to. So, okay. Other questions? Yes? Uh-huh. How do you get to the file? You have to copy it over to be in the same directory. So if you, I didn't do a good job on the web page, but if you look at the instructions on how to copy the program over, just below that there's an example of how to copy the data file over as well. And then once it's in the same directory, when you run it, all you have to say is camp.txt. You type, and no, you can copy the one over from my directory. And there's instructions on the web page as to how to do that. Yep, absolutely, and it won't edit my copy. So that's why I have you do your own. And by the way, when we test your programs, it's going to be tested with way more than just that single file. I'll have a bunch of different files I'll give the TAs. So you should be creating additional data files, because that one is just an example file. It doesn't test for everything, right? Like I don't believe there's any bad data values in there, are there? So it's not testing your bad data stuff. It's not, checking some things. So, other questions? Sir.
For the program, when we have like one error, are we just terminating, or
Yep.
do you want us to?
Just terminate. Right now we're just terminating. I mean, in the real world, if your program dies every time there's an error, you'll get fired, right? However, you've only been doing this for, I don't know, how long has this class been going on, like 3 weeks or something like that, right? So it's more than we expect of you right now. Yes, sir. If the person types the wrong name for the file, the program should terminate. Oh, well then you should prompt the user to ask for a good file name again. Does my program do that? Oh, it does? Okay. You all asked me about that a lot for the first project, so I think I put it in there just because I don't ever want you to ask me any questions again. And the way I punish you is that if you ask me questions, I put it on the project. Sounds fair? I'm totally joking, by the way. Please ask me questions. Sir? Uh-huh. How should you? Do you remember we talked about set width? I'd use that. That's what I used. And in fact, you can exactly reproduce my output if you count the number of spaces, if you just sweep over it with a cursor and figure out how many spaces are there. You don't have to exactly do that, but you have to do something that looks nice. So, yes? Uh-huh. I don't know, send me an email and I'll look at it. Oh, the first one does, the first column aligns left. Yeah, I did that because I'm a jerk. Yes, you should do that. Sure, why not? I probably didn't even talk about that in class, did I? All right, well then you don't have to do it. I'll show you how to do it today. Thank you for pointing out that I did that. So, yeah.
On Blackboard, there's only one assignment submission thing for Project 2, and I know that I submitted my algorithm on it, and then it got graded by the TA, and now there isn't one.
Oh, okay. There should be one. I set it up so that it should automatically, the old one should have gone away and the new one should have automatically appeared for your code. But I'll check today, because I realized today I forgot to extend the deadline on that one anyway. So I'll fix that today. But thank you for pointing it out. Anyway, and I didn't tell you about formatting left. Don't worry about formatting left. But if you want to, there's a trick. And the trick is you know we have set width and set thing. You just put left in there, L-E-F-T, in between the angle brackets. And then when you want it to do right, you put right, R-I-G-H-T. So anyway, I get carried away sometimes. All right, other questions? How y'all doing? Is there something good on the computer today? All right, so what we're going to do now is, because I've given you a bunch of stuff and we've been like desperately trying to make up for snow days, by now we're sort of made up-ish, and like after you watch the video for Thursday and we get through the rest of class today and Thursday, I'm actually going to be really comfortable with where we are, and so I can start doing more of the stuff that I like doing in class that I've been skipping. And the stuff that I've been skipping in class is, how many of y'all were here the first day of class? You remember I gave you all those weird projects and made you talk to people and do them? I like doing those in class because I like giving you sample problems like will be on the midterm. How many of y'all think that's a good idea? Sample problems? Yeah. So now we're going to start catching it up. And so I printed out a bunch of these, and we're going to do some of these today. We're going to do this in the partner assisted solving problem way we did on the first day, so go ahead and find a partner. Now what I'm going to do is I printed a bunch of these, and I'm going to hand them out to you. There are 2 sheets. They are not stapled, so as I hand these out, please make sure you are getting 2 2 sheets front and back. And then we'll talk about exactly which ones we're going to do first, because we're going to do a couple of these, and then I'll talk for a little bit, and then we'll do a couple of these, or maybe one. So introduce yourself, find someone next to you, say hi. Try not to. This is for you. All right, there's an extra one back here for Kelsey, who's in back there. So. Yes. Where did you find printf? Yeah. C out. Do C out. And printf is the C way of doing things. A lot of people use printf. Did you not get one? The string one. Really? Was your page blank? Oh, well, you should have had 2. All right. So the first thing we're going to do is we're going to do the CN functionality page. This is practice for how CN works. You should be good at this by now. I would like each of you to alternate. There's 1, 2, 3, 4, 5, 6, 7 different things. So I would like you to take turns, go back and forth. You don't have a CN one? I told you there are 2 pages. Did you all split up my pages? How many only have 1 sheet? Bad students. So which sheet do you have? You have the reading from files one. Here, I'm going to take this back. If you only have 1 sheet, raise your hand. Give me that back. Give me your 1 sheet back. Wait, now you have like 10 sheets. I will sort this out and be right back to you. All right, now who doesn't have any sheets because I took them all away? 3, 4. All right. Do not separate sheets, okay? They both go together. You get 2. Troublemaker portion of the class right back here. You have both? Oh, did you need one? Okay. Anybody else over here? And sir. Wait, did you get none? Did you? There's 2. Give me that back. You're starting with CN, the CN one. So, and then take turns. Each one do 1 line. So.
It'll just be 14.3. Oh, okay. Oh, Lord. We'll read X first. So X and then I guess J
All right. I'll give you another 20 seconds, and then we'll start going through these. All right, so let's go ahead and look at some of the answers on these. These should be relatively straightforward by now, and you can almost certainly expect a question on the exam covering this concept. So who wants to help me with the first one? Oh, way to move. This one's pretty easy. I is, and then what's CH? And X? 7.2. Where did these things come from? We didn't read these in. W and 7.2 didn't get read in. Where did they come from? They were already there. What happened to the initial values, right? Of I and J then? What happened to the 0 and 12? They are overwritten. They are irretrievable. Once you overwrite something, it's gone. Once it's gone, can you get it back? No. No, you can't. Okay, so that is correct. Here you go. Whoops, sorry, bad throw. Out of practice. All right, who wants to do the next one? Sir. Uh-huh. Uh-huh. Yep. Everybody think this is correct? Any abstentions? Okay, so the only thing we put things into I, CH, and X, but some reason there's still a value for J. Why is that? There you go. All right. Item number 3, which is CN into I, CH, and X. Everything's stacked up. What happens here? Why?
Because CN looks for the biggest of each of whatever its inputs are. So it's looking for the biggest integer it can do. So it goes 25, and then the left goes to count, and then there's the biggest crop.
Yep, it's exactly the same as before because returns that put things onto the next line are exactly the same as spaces as far as CN is concerned. So it makes no difference at all. All right, now we should be getting challenged. Who wants to do the next one? Sir. What? How can it be the same thing again? Okay, so we know CN is helpful, and CN tries to do what it can for you. And in this case, what it does, it says, oh my God, all this stuff is jammed together. 25p, 31.2, there's no white space at all. What is the biggest integer I can take from the beginning of that? 25, right? Because p cannot be part of an integer. Then it's looking for a character. And what's the biggest character you can pull out? P. Why not p 31.2? 31.2 is not a character, but how do we know that it's not getting more than the P? Because a character only stores one thing. Only one thing. How many things does a character store? Exactly. So we know that whatever is in that one slot is going to be the character, and then we output into X, which is 31.2. That's what's in there. All right. Step the next with 19 plus 0.759. Who wants to do this one? Yes. Uh-huh. 0.75. Any objections to this? Do y'all think this is right? All right. So we put 19, it goes into I. CH reads a character, is plus a character. Absolutely it is. 0.75 is a float, and 9 is another int, and we're good. Okay. How about item number 6? Who's the one, sir?
So I would be 19, A would be 12, the CH would be plus, and X would be 0.759.
All right. Oops. Does this seem correct? How many of y'all think this is correct? Well, what happened? Look, up above, we had everything jammed together, and CN pulled it all out correctly. Here, everything was jammed together, just like the line above, but something different happened. What happened? So here's the problem, right? The problem is we read I, and it was 19, and that was not a problem. We read plus, and that was the character, and that was not a problem. But then we got to the end, and we were looking to put things into X. And CN takes the longest thing it can, and the longest decimal it could find was 0.759, so it took that whole thing. Now what happens there in terms of putting stuff into J? There's nothing left. So what do you think a program that was running would actually do in this case? It would hang, yeah, it would just sit there waiting for more input. Now it's correct that at this point J would still be 12, but the very moment we typed in any other number, right? The very moment we typed in any other number, it would overwrite J. Everybody good on that? All right, then the last one. Who wants to do this one? Sir. 012W7.2. All right. Let's see if that's right. How many of y'all think that's right? How many of y'all think it's not right? Okay, let's work this one through. So the first thing that happens is CN angle into I. Is 14, what's 14? An integer? Is an I an integer? So this will work, okay? This will work. Then in something into CH, angle into CH, what is going into that CH? 3. Can 3 be a character? Is the character 3 the same as the integer 3? Absolutely not. Okay? You can have numbers be stored as a character, but remember they're stored by their magic code value rather than actual value. Then we come along and we get to X, and what's trying to get put into X? Can you put a Q into a float? What happens with CN when it does something? What happens? It quits on you. So the first couple of things were fine, right? Like it went through and it said, okay, I put something to I, that's fine. I put something into CH, and that's fine. But now I get to X, and you've given me a Q, and bad things happen. CN quits, okay? Now the newer version of CN sometimes puts zeros when it quits, sometimes. The old version did not do that. So this is either going to be what it was up above, 7.2, or it might be 0, depending on what the compiler does. And does J get changed at all? Well, why not? There's a 42 right there to read in. Because CN quit, and once it quits, it never comes back. Never, right? It doesn't come back on that line of input. It doesn't come back in the rest of the program. It's gone. It's gone. Now, I'll tell you one thing. If you're also, just like CN using the angle operator, if you're reading from an input file, what do you think happens if you're reading from an input file and you get the wrong kind of thing? It quits. It doesn't matter whether you're getting things from CN or whether you're getting things from the input file. Once you get to the wrong plot, it quits. Here's your consolation prize. I actually had a Twix bar for if you got it right, but only roll those today. Okay. So this stays the same, okay? CN is your friend. It will do its best to figure things out, but the very first time it gets a type error like that and it can't figure things out, it quits on you, and it never works again. Oh, sorry about that. Yeah, sorry, because it doesn't get changed. Uh-huh. That's what I would put. Like this would be the answer I would prefer to see. I would prefer you to know that things are unchanged and that it's waiting for input. That would be an appropriate thing. Okay? Sir. No. No, the compiler only puts, and I think it might only do it for ints. I haven't done a complete exploration of it. But I think it only put 0 for the thing that it couldn't read. Now, I don't know why they changed it to do that, but I'm sure that there was a big committee who argued over it for quite a while and decided that was best. So, all right. All right, questions on this? Yep. It will do its best, and it will just read the single character off of there. You don't need single quotes around it in this case, because once it's reading input, it doesn't read the... And in fact, if you put single quotes around it, the first single quote would be the character, right? So you can see some weird stuff. Yes? Mm-hmm. Yes. Yes. No. You don't need to know the ASCII values of things in order to figure out where they're going to sort. So that would be outside. So let me just take a moment and talk about the midterm exam. It's Thursday, right? I like saying that. No, it's 2 weeks from now. I'm going to give you, before the exam, like a week before, a list of topics and everything I expect to be on the exam, and I only write things that are on the list of topics. So if the list of topics I give you doesn't say memorize all the ASCII codes so that you're able to sort things, you will not be expected to do that. Okay? Make sense? I love messing with exam dates. It's great. Everybody's like, all right. I don't know. It's whenever it says on the syllabus and on the webpage. I didn't move the midterm. The midterm is on the same date it's been forever. It's 7th. That's the Thursday before spring break. Right? Does that sound right? It's like the day every other midterm you have is. Like we conspire and get together and find days that we can put all our midterms at the same time. So. All right. How's everybody doing? Questions so far? All right. Let's move on to the next side of this page, which is string functions. Again, work together as a pair. Somebody's going to answer, and I've got, I don't know, a Twix or peanut butter cup crept into my, I'm going to keep those for myself. So go ahead and work on those together, please. The code never lies. There are no trick questions. It just does what it does.
I think it's saying it's the same as saying string spaced out, and then on the next line, string spaced out. It's just making two strings. Or maybe that it's all
Yes.
When you're so comparing strings, but comparing like the literal character values of strings, like I want to put an escape function in where I could, if let's say I'm not finding the file that I want to enter, where the user can type exit.
You could just do equal equal quote exit. You could just never have a phone.
For some reason, I feel like when I try to do that,
Mhm.
it said I'm using Xcode and it said like invalid binary operands. Can't compare strings using I don't know.
You couldn't use equal equal? You might have to use a method called .compare, but equal equal should work.
And it has to be
The problem is that exit is probably a reserved word. I don't know. I'd have to look and see what you're doing. So.
So in your program, it shots off these
Wow.
decimal point zeros.
Mm-hmm. Is that my program you're running?
No, this is mine.
Uh-huh.
So I was wondering how you do that because I was thinking through the ways in which you can design an algorithm.
Ceiling and floor.
Okay.
All right. Everybody about ready? It's gotten quiet in here. Either that or I've broken your will to live. How many of you, your will to live is broken? How many of you are done? I don't care about you, so we'll go ahead. Who wants to go ahead and answer this one for me and walk me through it? Kelsey, right? Pardon? Oh, I'm glad you said so. All right. Let's figure out how this works. So the answer when you run this and it outputs project 1 was fun. Snickers? Right? It outputs project 1 was fun. Now, what we've done to get there, though, let's go step by step and see what's actually going on in here. All right? This is very similar to a thing I might give you on the exam, right? If I wanted to test you on this, I would write problems like this. The advantage of you having these problems is that you know like what type of problems I write. Okay? And in fact, if I'm in a good mood, I might even send you one of my old exams. I generally don't hand those out, but I might send you an old exam to look at. So, okay. How many of you want that? Nobody? Okay, never mind then. All right. So the first thing up there, string fake. What does that do? Pardon? Yeah, I just put that up there to help you count, right? It's a fake string, but if you look, the numbers go from... That's nice of me, right? Now, I may or may not do that on the exam, but, and the reason I do this, the other thing I might do on the exam, I might do this. Okay, so I put those numbers up there for you just so you could look and see, make it easier for you in this case, right? Because you don't have to number them yourself. If I put fake numbers in there, you should not fall for that, okay? Like if I start with a 1, what am I trying to do? I'm trying to lure you into temptation of counting from 1. Okay, we have ejecta frowns upon, which is just an anagram for project 1 was fun. I create, what does this thing do here? String out creates a string named, and string temp, what does this temp do? This creates a string named temp, okay? I just declared 2 variables at the same time. We never end up using temp, do we? I don't even know why it's in there. It probably was when I was designing the problem. I did something else. And we have int length right here, right? It's an integer. What value does this have right here? What value does this have right here? We don't know, okay? I didn't initialize it. And the reason I didn't initialize it is because I'm lazy. I'm going to initialize it right here. So next length becomes in.length. What is that? 18. Why is it 18? Because there are 18 letters in there, numbered 0 through 17. Okay, so now we know how long they are. So now we start putting together our output string. And out is initially empty, and we add in at leng minus 3, which is what spot? 15, and here, since I've conveniently numbered it, we can see it's right over the P. And so the first thing is P is in project 1. All right, let's just do a couple of these because, you know, once you get to this point, it's all kind of the same. We did in at substring 8, 2. 8, 2. What does that do? Sir? Uh-huh. 8 and 9. Yep. Okay. The thing to remember is that this counting starts counting at 0, right? So the place you take things from starts counting at 0. So it's correct here to say we're at 8 because we also included 0. If I had misled you by changing the number of the string that we had. And then it takes 2 characters, so it takes RO. And then substring 1, 4 takes JECT, which puts together a project. And then the rest of the F just go through and it puts together and says project 1 was fun. Everybody comfortable with these? All right, the plus sign concatenates. For any of these, I could have changed equals to just plus equals, and that would have been the same as well. Right? I probably should do that for next class. All right, everybody happy with this? Happy? Unhappy? Questions? Pretty straightforward, right? All right, so let's move on, and we're going to skip the one that says converting loops for the time being, and we're going to do the one that says reading from files. Okay, reading from files. Yes, do you not have that one? Anybody else not have that one? And no, hey, come on, talk to each other. This isn't a test question. One person do it, other person talk through. Too quiet. All right, it's getting quiet. That generally means people have solved it. How many of y'all think you're done? All right, who would like to be the one to do the first part and tell me what this program outputs? Is that the first part, by the way? Because I gave away my sheet. Okay. Who would like to tell me what the program outputs? Sir.
First we'll say the header line was this file contains a list of integers.
Uh-huh. So, yep.
Go to the next line, and then it'll say, and the sum was.
And what will the sum? No, I was just doing the math in my head to make sure you were right, because I forgot to write. Thank you. Seeing I'm math major. That's just what I need. So, okay. So the first part, it prints out this file contains a list of integers, and then it prints a sum. So let's look at how this happens. So we step through this. Some of this we should recognize through here. What is an IF stream? Pardon? You can think of it as something that is like the connection from your program to a file somewhere. An analogy that I've started using is that it's a hose, right? We have a disk, it's full of files, and we want to get data out of the files into our program, and the IF stream is like the hose that connects the tank of data that's the file to our program. Now, what we have to do is we have to tell it what file to connect to, and so we're telling it to connect to input.dat. Okay? We check and make sure that it opened correctly, and if it didn't, we return an error. Then the next thing that happens is we use getLine on input file, and this is the first time we've seen this, right? That you can read from using getLine from a file just like you can use CN. And when you do this, it reads the entire line at once. So let's take a look at the data file. So the first thing that happens is we use getLine, and see where the little red blinking cursor is right there? Right? Does that show up for you? So that is where the mark is on the file, and it reads all the way to the end of the line at once. So it reads all of that. That getLine will capture that entire line. Okay? And it puts it into the string header line. Then from there we go into the loop, and it says while input file angle num in, and what's going to happen is it's going to read each one of these number in sequentially, one after the other. And each time you do that, it's going to add to this sum. All right, sum is an integer. It was declared up here and carefully initialized to 0, and each time it's going to be sum plus number in. So when we're done, when we output, we have the sum of all the numbers we read. Right? Everybody good with that? Questions? Sir?
When you do the initializing for num in and sum, does it initialize them up to 0?
It does not. It only initializes sum to 0. You have to put a separate equals for each thing you want initialized. I should be a better person. I should initialize all my variables. I think I warned you on the day that I talked about initializing variables that I'm lazy and I don't always do it. So it's good practice too, but I didn't do it here. Other questions? Sir? So CN is what? The keyboard? Specifically the keyboard, right? C out goes to where? The screen. C error also goes to the screen. However, it's a special thing for error messages, and there are ways that you can tell whether something was an error message or output. I normally don't teach it in this class because it doesn't get used that often all the time. So, but you can, absolutely. And in fact, when I'm writing my programs and I want an output statement, I normally use C error for output, like when I'm just adding a temporary debugging statement. And that way, when I want to go through and take them out later, it's easy to find them because they don't look like C out. So, but you can use it. Other questions? All right. Wait, who helped me on that one? All right, who wants to tell me how we can get a count of all the line numbers? All right. How do we do that?
So you can initialize the counter variable and make counter equal to 0. And then in your while statement, you want to do line count plus plus at the end, which will increment it every time you run the while loop.
Mm-hmm. Just like that, right? That should work. So earlier at the beginning of class, I was asked how to do something like this, right? This is essentially exactly how you do it. You create a counter line outside, something that counts outside, and when you go through, you can either count the number of lines, or if you want to do some processing over everything, you can do the sum. So that's how we do that. All right. Everybody get this? Everybody happy? On a scale of 1 to 10, where 1 is abject despair, 10 is giddy joy, how many of you are at like a 6 or more? How many of you are less than a 3? Oh, okay. That was very inconclusive, so there's a bunch of people there in the middle range, I guess, which is fine. All right, any final questions on this? Otherwise, we'll talk about something briefly. Questions? All right, everybody stand up for a minute. Just stretch in place while we switch over to doing something new. It scares me. I know, it just scares me. It scares me. You know what I actually do sometimes if I have to put it on the floor is I stand it up on its side. Really? Yeah, so it's like on the edge of the screen. So, yeah, because it's harder to step on that way. Yeah. This keyboard scares me more because it can crack your logic board and then your whole computer's dead. Yeah. Absolutely. 100,001. I think so. Wasn't it in the project specs? Yeah, I didn't put that in the first project, but somebody asked me and I hadn't put a limit, so yeah. And then weird things were happening if you got too large. So yes, for the time being. Yeah. It's an artificial limit. If you want it to be bigger, you can, but that's the specs right now. 100,000 or less, which rules out 100,001. Yeah, somebody was actually doing a very good job of testing their program last time, and they were putting in like hundreds of millions of refugees. And it turns out that they were putting in enough that weird things were happening with the math because it was overflowing out of the number of bits that. So I put in a limit. So you probably won't experience that. You should make sure it's part of the project spec this time that there will not be more than 100,000 refugees in any particular camp. So. Yeah, you do. That'll be one of the test cases. So. Anyway, I have to say I'm often pretty proud that I managed to like pick project topics that end up being topical. Like last semester we did a heart attack risk score, and then there was a big thing about that. And now, like this weekend, I was seeing all these horrible stories about Syrian refugees, and I was kind of like, I wish I was wrong about this one. So. Seriously. Okay, so we've talked about, if you watch the videos, we've talked about a couple of kinds of loops. Somebody name a kind of loop. Ready, go. A for loop. What is a for loop used for? What is a for loop used for? When you want to do something and you know how many times you want to do it. It is typical to use a for loop then. You can use it for other things, but a for loop is typically used when you want to do things a certain number of times. So, let's say we wanted a for loop that would print out all the powers of 2 less than 1,000,000. How would we do that? Is that going to be a fixed number? Yeah? So how would we do that? Yep. Start at 1 just to make it easier. Uh-huh. Mm-hmm. Okay, so we're talking about powers of 2. Powers of 2 start at 1. What's the next one? And what's the next one? And what happens each time you go up a power of 2? You multiply by 2. So I becomes equal to itself times 2. And then we can see out I. And this should print out a bunch of powers of 2. We'll just check it and see. What? Did I mess something up? I thought I'd fixed it. Okay. All right, and there's a bunch of powers of 2 for you. All right, those look familiar yet? No? 64 a power of 2? How about 196? Is it a sum of powers of 2? Yes. Okay. Anyway, so that's a for loop, right? A for loop, we're going to do things that we know a fixed number of times. What other types of loops do we use? And what's that for? Mm-hmm. I don't think I spelled that right. I'll take that I out. How's that? Close enough? Any English majors in here? Good. No, spelling doesn't count. All right. So let's say we wanted to write this for loop as a while loop. How would we do it? Yes. Let's just use X, just not to confuse things, okay? Mm-hmm. I'm using X now, not I. Okay, so now we have a while loop that does exactly the same thing. So a while loop and a for loop will do exactly the same thing. The nice thing about a for loop is that the notation is much more compact, right? Everything fits nicely in one line. You have your start condition, your end condition, and your increment condition, all in one line. We can do exactly the same thing in a while loop. We have a start condition, an end condition, and we have to put the increment condition in there someplace else. But they do exactly the same things. All right? Now there's one other kind of loop. One other kind of loop that this language supports. Anybody know what it is? Been reading ahead in the book? A what? A do loop. So the other type of loop is a do loop. And what is cool about a do loop? What is different about a do loop than any other loops? The loop will always do it once. Every single time this loop will execute at least one time. Because it looks like this. You say do, open parentheses, and then down here you say while whatever your condition is. All right? And what happens is as it's running along, it says, okay, do this stuff. And it gets down here and it says, oh, while this is true. All right? So what I'm going to do is I'm going to show you something here. Let's just do the same thing again. We'll use int y equals 1. We're going to see out angle y, angle in there. And then y times equal to. So we'll double it every single time, and we'll do this while y is less than 1 million. Okay. So this looks like it should roughly be the same thing, right? Everybody good with this? A do loop is just like a while loop, except you say do all this stuff while there. And the loop will always execute at least once. Regardless of whether the condition is met or not, it will execute at least once. If you look for a for loop will not necessarily execute at least once because it does this check here, and a while loop may not execute if this check doesn't get met. Everybody with me? Yes? Okay, the classic example of some time that you want to use a do loop is if you are reading a choice from a user menu. Because you always want the menu to appear and the user to choose something at least once. It could be that the menu appears and the user immediately chooses to quit and doesn't choose any other things and then you're done. But you want to make sure it appears at least once. Okay? Algorithmically, a while loop and a do loop are pretty much the same. It's just that if you are ever in a situation where you want to make sure it happens at least once before you do anything else, you can do a do loop. And I mean, I can draw the flowcharts for these. Essentially, the flowchart looks like this for a while loop, right? If you're done, yes. Otherwise, do the body of the loop and go back like that. That's a while loop. A do loop looks like this. You come in and do the body, and then you decide if you're done or not, and then go back. Does that kind of make sense, flowchart wise? So if you're still iterating, do that. No. Sorry, reverse these. No. Yeah. So this is a while loop, and this is a do loop, and they just flipped where the decision happens. That's all. All loops are interchangeable with some effort. It's possible to interchange loops. You can use in one loop for another. It can be kind of painful to do, though. So we're lazy. We always choose the best loop that we have. Sir? Yeah. So this is just a flowchart version of the while loop. In a while loop, you come along, and this diamond is a decision. And you see if it's true. If it's true, you do what's in the loop, right? And then when it's not true, you exit the loop. And you can see that if you come to the while loop and this is not true, you're never going to do the body. You'll just exit right away. Does that make sense? Whereas the do loop, you come along and you always do the body of the loop first because you're not checking whether you go back up again until you're done later. Okay? So the classic example of a do loop is for menu. We're going to use it here and see what happens. So here we have starting at 1, output double, while y is less than 1,000,000. Let's see what happens here. We should, if this works correctly, I forgot a semicolon. Semicolons are always important, aren't they? If this works correctly, okay, what we should see is we should see the same powers of 2 print out 3 times. And let's see what happened. Here's the first time. We go from 1 to 524, 288, 1 to 524, 288, and 1 to 524, 288. So all 3 of these loops are the same. All right? Yes? Mm-hmm. Thank you. So the question was, what happens if we don't start at 1? What happens if we start at 1,000,002? So what I've done is I've changed our initial condition for each one of these loops from 1 all the way up to 1,000,002. Now what's going to happen to the for loop? Is the for loop going to run? It's not, because it does the initial condition, it does the check. If the check passes, it does the body, and then at the end of the body, it does the increment. Yes? Yeah, I kind of wish I could put commas in here. Wouldn't that be nice? Okay, anyway, thank you. Here. Whoops. That's why they're in wrappers. Oh, are you okay? Sorry about that. Okay. All right, so now we've changed our initial condition. Instead of starting at 1, they're starting at 1,000,002, rather than 10,000,002. So let's see what happens now. What's going to happen with the for loop? Is it going to run? Is the while loop going to run? Is the do loop going to run? Yeah, so we'll see the do loop run exactly 1 time. So it compiled without error. We run, and this is the output of the do loop. Okay. The loops are roughly identical. They really are. They're roughly identical. You can do anything with any type of loop. The different way we note it is sort of a convenience factor, right? Does that make sense? Yes? Great. So let's go ahead and do the very last problem on there now, which is called loop conversion. And it's asking you to convert a loop, and I hope I didn't do exactly the same one. Change a while loop to a do loop and a for loop. You could. If you put it in parentheses, I plus 1 and I plus plus and plus plus I are all the same. If they're in parentheses, so that it evaluates first. Actually, they're not all the same. But you could use plus plus I, yes. All right, who's done, roughly? How many of y'all got the for loop? How many got the do while loop? All right, who's going to help me with the for loop? Yes? All right, so we replaced x with I. Nice pick while you were reading along. I was impressed you switched from I to x. Good notice. So I just used a different variable here so we can keep the loops separately. X equals 0, x less than 50, x equals x plus 1 times 2, see out x. Sir? No. But I don't want to get into when you can use different variables and not right now, so it's just easier to not. We'll talk about that later in the semester. Okay? All right. Sir? You can just put x inside the loop. You can. Can you initialize it outside? You can, but as we'll see later, it acts slightly differently, a little bit differently. It wouldn't make any difference in this problem, but it would make difference other times. So, okay. Does everybody think that's right? Should we run it and see if the two things print out the same? What do you think? Compiles nicely. All right, we see 026 1430, 026 1430. Bravo. Almond Joy? Snickers? Twix? Nothing? All right. So who's going to help me now do the do while loop? Yes? All right, I'm going to use y for this one, just for fun. Mm-hmm. Like that? Does that look about right? All right, does that look better? So let's compile this really fast and see what happens. All right, 0 to 30, 0 to 30, 0 to 30, we're happy. Now, let me ask you a question. Let me ask if I wrote this question otherwise. Here I asked you to just tell me what the equivalent loop is. What if I wanted you to write the equivalent, oh, sorry, Almond Joy? What if I wanted you to write a loop that would work for every single possible initial value? Every single possible initial value. So let's say I wanted this to work always, even when I was like 100. So what if I wanted to do this for any possible value of I? Yes? Well, if this is our initial loop, right, and I wanted you to make these other loops work for every possible initial value of I, not just 0, what would you have to do? Yes? No, not quite. So what's the difficulty? What happens when I make this 1,000? When I make I 1,000, I make x 1,000, and I make y 1,000. What's going to happen? How many times will this while loop run? How many times will this for loop run? How many times will this do loop run? Ooh, that's a problem, isn't it? So what could we do to this loop to make sure that it always only ran when it was supposed to? Nope, you could put a while inside of a do. We'll talk about nested loops later, but what can we do to fix this one problem? Pardon? An if statement. So the problem we have is that We have the problem with this loop that it doesn't check before it runs. So if we want it to be exactly the same, we have to put an if statement around it so that it checks before it runs. Okay? Other than that, all the loops are identical, and they do the same thing. Sir? You could do it differently. There are other ways to do it, yes. So. All right. Everybody have a good, yes, question? How do you choose which loops to use? If you don't know how many things you're going to be using, and the answer, it could include 0, you use a while loop. If you know how many things you're going to be doing, you use a for loop. And if you always want it to run at least once, you use a while loop. That makes sense? All right, have a good Wednesday. Hopefully we'll be here Thursday. See you later.